Gemma is cold and is warming herself up.
Bet you didn't know friction is used when you're trying to warm up your hands on a cold winter day.
By definition, friction is the ever-present resistance to motion whenever two materials are in contact with each other. But in simple terms, friction occurs when two surfaces rub together and their stickiness causes frictional forces.
There are two types of friction. Kinetic friction, also known as sliding friction or moving friction, is the amount of retarding force between two objects that are moving relative to each other. And static friction, the friction that exists between a stationary object and the surface on which it's resisting.
Here's an example of kinetic friction. If we push this ball across the floor, it will come to a stop all on its own. The force that is bringing it to a stop is called frictional force. When the ball is moving, kinetic friction acts upon it. It is also an example of static friction because when the ball is right before it is pushed to move, the ball is at rest, meaning it is static.
Now we are going to do some example problems using the friction formulas. First, we are going to introduce a new symbol. It's called mu, and it is the coefficient of friction. This is a decimal between 0.0 and 1.0, meaning that this cannot be more than 1. Mu has no unit, unlike the other variables we will describe.
To start, here are the different variables we will be working with. The first is F, also known as the frictional force. The unit for this is newtons. The next variable is mu, which we just talked about. It's the coefficient of kinetic friction. That is the K for kinetic. The next variable is mu s, the coefficient of static friction. And remember, these two don't have variables. The last variable we will be working with is Fn, which is the normal force acting upon the object. This is also measured in newtons. This problem describes a hockey puck being pushed across the ice. The coefficient of kinetic friction between the puck and the ice is 0.15. A 2.6 Newton push force of the push is applied to push it to the right. The normal force acting upon the puck is 9.8 newtons. Now we will do a problem to find the frictional force. So our formula is F, frictional force, equals mu K, which is kinetic, times Fn, normal force. We now plug in the things we know. We don't know this, that's what we're trying to find. We plug in 0.15 times 9.8 newtons. That leaves us with 1.47 newtons as the frictional force. There we have it.
This problem describes a huge pile of leaves wrapped up in a tarp. The leaves weigh 580 newtons. The coefficient of static friction is 0.55. This is going to be the same formula as our previous formula, but we are finding the frictional force required to start sliding the leaves, known as mu s, static. So we set up our formula. So you do F of F, which is frictional force, equals mu s times Fn. So you don't know frictional force, that's what you're trying to find. So you plug in everything you know. So 0.55 times Fn, which is, as you see in this diagram, and as I put here, 580 newtons. And then when you multiply them together, you get 319 newtons. We hope you learned a lot about in this video how static and kinetic friction work.
Now you know how to find the frictional force of objects in your everyday life. Thanks for watching. And remember, be kinetic!